See students, this is how the structure of naphthalene is. Its molecular formula is C10H8. Actually it is aromatic hydrocarbon, because whenever you will find the ring, this will be known as aromatic hydrocarbons with with alternate double and the single bonds. So here I have not shown carbon atoms, but you have to consider that these corners will be occupied by carbon atoms, and to the carbon atoms hydrogen atoms will be connected. And if you want to see that how these carbon atoms or hydrogen atoms are there into the naphthalene ball, this is how the structure is going to be. And there you can show this carbon atoms and the hydrogen atoms. So see, these are the carbon atoms. 10 carbon atoms are going to be there and 8 hydrogen atoms. Only this and this carbon atoms will not be occupied by the hydrogen atoms, because there are the double bond. Because here the valency of carbon atom has already been satisfied. The valency of carbon is 4. So this is double bond, this is one single bond, this is one single bond. So now carbon atom will not be able to attach any other atom along with it at this moment, because already its valency has been satisfied. Same thing will happen with this carbon atom. From this side one carbon atom single bond, from this side one carbon atom single bond, from this side double bond. So here the valency 4 of carbon atom has already been satisfied, so we cannot connect any other hydrogen atom or any other atom along with this carbon atoms. Only these 2 carbon atoms are left without the hydrogen atoms. Rest of all the carbon atoms has been connected with hydrogen atoms. So this is how the structure of naphthalene is. All I want to say you is that such unsaturated hydrocarbons or aromatic hydrocarbons have more percentage of carbon into it, and that is why it burns with yellow flame and gives a sooty flame. Sooty flame means soot particles will be suspended into the air. And as we saw into the case of ethanol, ethanol was saturated hydrocarbon. It was having less percentage of carbon atoms, less amount of carbon, and that is why it was burning with a blue flame, a clean flame without any soot particles suspended into the air. So whenever aliphatic or saturated hydrocarbons will be burnt on a copper gauze, it will give us a clean blue flame, while whenever unsaturated or aromatic hydrocarbons will be burnt on a copper gauze, it will give us a sooty flame and a yellow flame. So this is what we studied into combustion. Now let's move towards oxidation. Oxidation, you all know this is another chemical property of the hydrocarbons, that whenever hydrocarbons will come into contact with any oxidizing agent, oxidation will take place. That means addition of oxygen and removal of hydrogen will take place. And one more thing I would like to tell you over here, one note is given that there are inlets for air in the gas or kerosene stove at the home. Inlets means there is a space for the air to go and to come in. And why that space or those holes are there into the gas stove or the kerosene stove? So that oxygen will combine properly with the fuel, and the complete combustion of the fuel will take place without any wastage. So that is why those inlets are there. Now let's move towards the activity which is given over here. Here potassium permanganate, or you can use potassium dichromate also as an oxidizing agent. Now oxidizing agents are those agents which brings about the oxidation of other compound which are coming into their contact, and they will get reduce itself. That means they will remove oxygen from their own attachment of oxygen will not be there with them, but this will get the oxygen attached to the other compound which are coming into its contact. So an oxidizing agent affects on certain functional group in present carbon compound. So here you have to take 2 to 3 ml of ethanol in a test tube, and you have to add sodium carbonate solution to it. Then you have to warm that mixture. Then drop wise you have to add potassium permanganate. Molecular formula is KMnO4. So what you will notice that the pink color of potassium permanganate will disappear. So why that pink color will be disappear? Because all the particles of the potassium permanganate will be used for oxidation. And how this potassium permanganate will be oxidizing that ethanol? Because that potassium permanganate will release the nascent oxygen. See, this is the nascent oxygen which you will get from KMnO4, and then that oxygen, which is highly reactive, this nascent oxygen is highly reactive, it will try to remove these two hydrogen atoms and will get associated with this carbon atom with a double bond. So then it will be resulting into formation of ethanoic acid from ethanol. So this is how the reaction will take place, and this is how the oxidation of the ethanol will take place in the presence of KMnO4. So that is why it is said that the pink color of potassium permanganate will be disappear, because all the particles of potassium permanganate will be used for the oxidation reaction, and at a certain point of addition, oxidation of all the quantity of ethanol in the test tube is complete. If the addition of potassium permanganate is continued beyond this point, it is not used up and becomes excess. So what is told over here, that if you keep on adding potassium permanganate, but ethanol is not, the quantity of ethanol is not enough to get reacted with potassium permanganate, then the entire ethanol will be used up, and then only potassium permanganate crystals are going to be there into the solution, and then you will notice that the pink color will remain as it has. But as long as there will be presence of ethanol, if the ethanol has not been used up, that ethanol will keep on reacting with potassium permanganate, and then at that time the pink color will disappear. And if the ethanol will be used up, and if you still keep on adding that potassium permanganate, then the pink color will stay as it as. Now how this nascent oxygen is liberated from KMnO4, I would like to show you over here. See, KMnO4, it will decompose, it will give us potassium magnate K2MnO4, then manganese dioxide, and this is how nascent oxygen will be released. And then this nascent oxygen will come in contact with ethanol, and then this hydrogen will be removed, and double bond oxygen will get associated with carbon atom, and this is how ethanoic acid will be formed from ethanol. So rest of the things we will study into next video. Till then, have a knowledgeable day. Thank you.